We are back with solving equations with variables on both sides. This is part 2. So hopefully you've gone through part 1. You feel really comfortable with moving variables from one side to the other. Now we're going to look at a couple of word problems, and I'm going to show you one way to set up an equation to solve these. There are other ways that you can design these equations, so feel free to branch off and come up with your own equation and manipulate it the way that you see fit. As long as it is meeting the requirements of the word problem, you have an equation and your answer is obviously the correct answer or matches the answer that I get, then you're on the right track and you know what you're doing. So feel free to go ahead and do that. If not, we need to look at this together. And when you approach a word problem, we've talked about this in another video, you've got to be very careful. You've got to pick out the important information, forget about the other stuff in the word problem, and really just think it out. If you need to talk it out loud, then talk it out loud, but just think through the problem before you ever start writing anything down. So what I'm going to do is I'm going to start highlighting some things that I know is going on here. In the first sentence, it says that she pays someone $35 to clear her driveway when it snows. Okay, so $35 is how much she's going to pay when it snows. Not just for one winter, but every single time it snows. Okay, so if that were Franklin, she probably wouldn't have to pay $35 very often. But we're somewhere else here in this word problem. So $35 every time it snows. That's what the first sentence tells us. What she wants to do is buy an electric snowblower, and that's going to cost her $689. That is the snowblower. She wants to start doing this herself instead of paying $35 every time. She just wants to make a purchase so that she can clear her driveway herself. Now, where she lives says if the area Laurel lives has an average of 5.2 snowfalls. 5.2, so quite a few snowfalls. She has 5.2 snowfalls each season. We want to know how many seasons. And I'm actually going to pick a different color here. How many seasons? That's the question that we have to answer. How many seasons will it take her to break even on what she spent for the snowblower? So let's think about this before we ever start writing anything down. This is what I like to do with word problems. When I approach this word problem, I want to think it out. I want to think about putting myself in the situation. Okay, every time it snows, I'm paying someone $35 to come to my house and clear my driveway. Where I live, I get an average of 5.2 snowfalls. So nearly 5 snowfalls every year. I'm going to pay someone $35 for each one of those snowfalls. So I decided I'm going to pay $689 and buy myself a snowblower. I'm just going to do it myself. So we want to figure out how many seasons. Kind of think of it how many years, if you want to think of it that way, but how many seasons will it take her to break even? Alright, so let's first, since this is what we need to find, seasons, let's go ahead and let's make S equal seasons. Since that is the question, I want to know how many seasons. Let's go ahead and identify what our variable is going to be. That's a good place to start when you get to word problems. So S is going to be seasons. So now let's go back up and let's think. How many seasons or how many snowfalls do we have each season? Okay, one season we have 5.2. 2 seasons I would have 5.2 times 2. Okay, and then 3 seasons, 4 seasons, I would add 5.2 every single time. So if we don't know how many seasons, that's our S, our seasons are unknown, then we don't know how many snowfalls total we're talking about. Could be 1 season, could be 2 seasons, we don't know. So a good place to start would say 5.2 snowfalls per season. Usually when you hear per season, you're talking about multiplication there. 5.2 snowfalls per season. Alright, now let's back up even further. What do we know about the snowfalls each season? Well, in the very first sentence, it tells us that every single snowfall, she pays someone $35 to come and clear her driveway. So this person, if it were one season, we could think about that over here. We'll do a little kind of thought cloud here. If it were one season, 1 season. I'll write this in. Okay, that is 5.2 snowfalls times $35, because this person wants to know, well, how much money am I going to make? I mean, if it's going to snow 5.2 times, and we're just going to leave that 0.2 in there, but if it's going to snow 5.2 times, then how much money am I going to make off of Laurel? Well, at $35 per snowfall, you're going to make about $185. So in 1 year, 1 season, Laurel's going to pay $185 for someone to come and clear her driveway. But let's back up here and think. We don't know how many seasons. We know it's 5.2 snowfalls per season. We know it's $35 for every snowfall. But this is the number we have no idea about. That's what we have in green here. We got to know how many seasons. So what we can do is 5.2 times S is going to tell us how many total snowfalls over however many seasons we have. So if we multiply that total amount of snowfall by $35, that's going to tell us how much this person's going to make. So if I plug in, say 3 there, after 3 seasons, okay, I could do 5.2 times 3, that's a total of 15.6 snowfalls, times $35 every snowfall. Someone would make $546 in just 3 seasons. Okay, so quite a bit of money there. So that's what we're trying to look at. How many seasons are we going to need in order to break even? Okay, well, break even means however much she would have to give out every single snowfall over and over and over. When will that equal the amount that she's going to pay for the snowblower? Now, she's got to pay $689 up front, but basically we want to know, how long is it going to take for her to get her money's worth? How many seasons is she going to have to clear her own driveway in order to make her money back, basically? Break even. So there's your equation. Now, variables not on both sides here, but you could design this in order to set up variables on both sides. But here we have just a simple equation. And this is not the distributive property because we cannot distribute over multiplication. This is just strictly a multiplication problem. We could use the associative property and change our grouping and move our grouping symbols. But we can just go ahead and multiply these how we see them, just 35 times 5.2. And that's going to give us 182 S equals 689. Alright, so 182 seasons, 182 times our seasons equals 689. 182 times S. Inverse operation there would be to divide both sides by 182. 182 divided by 182 gives us 1S. So 689 divided by 182 is going to give us, I'm going to round, we get 3.78, but if I round that, it would be 3.8. So we're talking about approximately, it's my little squiggly sign there, approximately 4 seasons. By the time that we get to the end of the 4th season, she will have broken even on her snowblower. So being able to set up a problem, and just noticed I put 185, that should have been 182 over here in my little thought cloud, sorry about that. But breaking down the word problem, thinking about it logically, putting yourself in the situation, and then designing your equation around that. So what I want you to do is, let's look at this equation or this word problem. So I want you to pause the video, take a moment to read through it, rewrite it if you need to, highlight on your own paper, or just pull out the important information from the screen and write it on your paper, but try to answer this question in how many months will the copier pay for itself? Alright, hopefully you are coming back from pausing your video and you're ready to check your answer here. One thing that I would like for you to do is make sure that you have highlighted or pulled out the important information here. So I'm going to do this in yellow, I think. I'm going to pick up yellow here. He spent $650, so quite a bit of money, on a copier. So he bought a new copier for the office. And what's nice about this copier is that it reduces. So that's important right here to think about. You always want to pull out, what am I going to add, subtract, multiply, divide. Let's see what's going on with our numbers here. In this case, it's reducing the monthly electric bill from 112, so that's how much they were paying a month, because this is monthly. Okay, keep that in mind. So they were paying 112 a month, and now they're going to pay only $88 a month. So quite a bit difference, quite a big difference there in 112 and 88. And the big question here is in how many months? So months is very important here. So what you should have done hopefully there is written out what your variable represents. And I'm going to use M to represent months. So let's think about this logically. You were the one that was paying the bills. How much were you paying every month for the electricity? Well, if you were the person paying the bills, you were paying $112 every month. Now, we don't know how many months. That's our variable. So we were paying $112 every single month. Now, your electric bill is not free, so you're not going to make your money back. You're not going to break even, or the copier's not going to pay for itself really quickly because you're still having to pay an electric bill. But it has been reduced. So that's subtraction. You're taking away how much money? Well, you're down to $88 per month. So if we were talking about just 1 month, if our M was just 1, then in 1 month you are saving $24, which is pretty good. Now you're going to save $24 every single month. So we want to know how many months is that going to take to equal $650? Because we want to know, when does this copy machine pay for itself? How long is it going to take until we actually are going to start saving money? We got to get this $650 out of the way, and then all the rest of that money each month we are saving. So 112 months, 112 M minus 88 a month, so minus 88 M. These are like terms. They are on the same side, so that's nice. We'll do exactly what it says here. We will subtract those. So 112 minus 88 is 24. Like we just said a while ago, we're saving $24 every month. We want to know how many months is it going to take us to reach $650 so that our copy machine pays for itself. Well, now we're down to a one-step equation. Very, very simple here. The inverse operation of multiplying by 24 would be to divide by 24. 24 divided by 24 is 1, so we're left with 1 month equals, and we have 650 divided by 24, which leaves us with 27.08, so 0.1. We'll round that to 0.1. Alright, so we'll say approximately 27 months. Thinking through a word problem, putting yourself in the situation, highlighting, writing it down, working it out. Hopefully you feel a little more comfortable with your word problems. So now you're ready to move on to variables on both sides, part 3.